Hi, Hamid. I couldn't hear you. I cannot hear you. Okay.
You mute your micro.
Can you hear me now?
Okay.
Yes, yes.
Okay, sorry, I don't know. There's several technical issues. Okay, so we have three types of missing values: either completely at random, missing and random, and not at random or systematic missing. Just three examples. For example, some survey questions is not answered randomly. It's just completely at random. When there is an association, we say it's not completely at random. For example, this one in service occupation less likely to report income. Maybe there's some social stigma to certain occupations, and also maybe somebody who has less income, they may not report their own income. So basically, if your missing value, which is y, depends on some other factors, or it depends on itself. For example, the last one, it depends on itself. If your income is too much low, maybe there's social stigma, you don't want to report it. In some countries, it's different. If your income is too much, you don't report it. Maybe it's because of tax purposes. So anyway, the only way that we take care of it, usually it's better to use some algorithms to impute the missing values when it's completely at random. But when it's missing at random or non-random, we don't want to impute the data. What I mean impute means instead of missing values, you put some numbers. So there's some algorithms that you impute the missing cells, and we just talk about them a little bit. Some of them are very easy algorithms. For example, you can easily find the median or mean of a column, and when your missing value is completely at random, you just impute with them with the mean or median. In other cases, you do prediction. For example, you consider the missing value as y and use the other variables to predict the missing value. When your data set is too large, we don't use such algorithms. We don't do prediction. We just impute with the mean or median of the column. At the end, when you do imputation, you don't create a new data. We just want to keep a certain columns or observation to insert into our model because we don't want to lose some observational columns. But we don't create any data. And other approaches, it's just, let me see. You just delete the observational columns. So this is the very old approach for taking care of missing values. If it's not completely at random, just drop them. We don't care about them. But if it's completely at random, it's not a good idea actually to drop your observations. First of all, when you impute properly, you don't create any data, so it's totally fine to use it in your model. But when you delete, let's say for female, for credit card assessment, I have too many missing values for the female that are completely at random. So if I drop the female observations, my model won't train very well for female cases because I don't have that much of information. Or when I drop columns, I lose some variables. So again, if your data is completely missing at random, just keep it and impute it. Don't drop rows and columns. Unless it's too empty. Let's say 95% of your column is empty, just drop them. Or 95% of an observation is empty, either missing at random or not, just get rid of them. But again, you have imputation, and you can easily impute with the mean or median or column, and that's totally fine. Any questions so far? The way that you find in your project, the way that you most likely in many projects you are missing values. You can just trust your judgment about missingness. You need to judge if they are completely at random or there's some association, and that's totally fine in your project. And you don't have to do very complex imputation or predictive imputation, just mean or median is enough. And we also talk about some modules later, how to do imputation when you have missing values in your data. Another approach is paired deletion. Let's say I just want to take care of, let's say I want to do a t-test or between 8th grade math test score and 12th grade math score. In that way, I don't need to take care of missing value in gender, because I just want to have these two columns. In those cases, maybe you drop the rows that are empty. So they call it pairwise deletion, but again, there is imputation. And or you want to do some correlation between gender and 8th grade test score. Maybe in pairwise deletion, you drop this row and this row, and you don't care there's a 3 missing values in the 12th grade math score. It's just another approach for taking care of missing values. But again, I recommend to use imputation. Because if you drop, people ask you why you dropped. And they ask you if it brings bias or not. So it just brings several headaches for you guys. So there's some complex approach for evaluating your imputation. So I don't expect you guys to do your project. It's just for your information. So what they do, they might do several approaches of imputation. Maybe impute with mean, median, pairwise deletion, or like predictive, different approaches of predictive imputation. Then they do analysis and predict, and then they take care of variance. And they see if there is a huge differences in different imputation approach or not. But this is a very complex way of imputation analysis. Basically, you want to look at the value of your missing values. So if there is a huge variance when you do different imputation, it just tells you that you lost a very important information. Maybe you need to do your data gathering again, because when you do different imputation approaches, you see a lot of variance in your outcomes. It just maybe saying that your imputation is not a good approach, and maybe you need to do data gathering again. But if the variances in different imputation approaches close to each other, it just doesn't matter that much, and just go ahead and pick one of them for your imputation. Again, it's too much of thing in your project. You don't have to do several imputation and analyze the variance, but for just further, it's just for your information and further analysis. Or if you have a project that missing values might be challenging, might be a good project actually. So maybe you can, if it's important in your project, that's for me totally fine. You can do just imputation analysis. Just do different imputation approach, estimate the variances, and just tell me that importance of the values that are missed and the problems that they might bring. For example, if it's a regression analysis, you might tell me that different imputation bring me different slope of regression. It seems that we miss a very important information that just at the end you might have several very different slopes based on the imputation approach. Okay, let's talk about a little bit about some statistical measure. So, do you guys remember what is the distribution of data? Or histogram? Histogram is talking about frequency of your data in different ranges or sub-ranges, similar to, and it's basically what your distribution is talking about. So when your data is skewed to the left, like here, it means most of your observation on the right side, but you have some very far observations over there, and it's not, they are not outliers actually, they are not just one or two. Several of your observations are much lower than other observations. If your distribution is skewed to the right, it means majority of your observations have are focused here, but you have some a significant portion of your observation much more than the others. And as you see, when it's symmetric, mean, median, and mode are almost same. When it's skewed to the left, median are lower, mean are lower, median middle, and mode in this part, because the height of your distribution talking about frequency. If it's skewed to the right or positive skewness, mode is here, median in the middle, and mean is in the right side. So the reason we are taking care of shape of the distribution, because in some analysis you use a statistical formula. For example, for regression, for simple linear regression, your data need to follow normal distribution, or your data should be symmetric. When your data is skewed to the left or right, you need to transform your data. For one of the ways, you do natural logarithm of your data, or do the square root of the data. Basically, do some change on your data set. And instead of doing the regression of x, you may find y versus ln of x, or natural logarithm of x. Because this is the limitation of a statistical model, your input should be normal. But when we use machine learning, you don't have to have normal data. So if your even data is skewed to the left and right, that's totally fine. You can use in almost all the machine learning algorithms. This is one of the reasons that machine learning algorithms are so popular, because they are much more flexible and you are not limited to normal data sets. Also, we have kurtosis. So your data set could be leptokurtic, means there is a high frequency near mean. Platykurtic means low frequency in the mean and therefore low and up, and mesokurtic, which is a normal distribution. And again, there is some test for kurtosis to see if your data has kurtosis or not. And if you want to use normal distribution, you should take care of skewness and kurtosis. But let's say if you use normal distribution, SVM, those kind of things, you don't need to take care of such a thing. So in your analysis, if you use a statistical model like linear regression, I would check if your data follow normal distribution or not. I talk about that. But interestingly, in many even machine learning algorithms, sometimes it's better to transform your data to normal distribution to have a better performance. So what happens? Maybe you use normal, maybe your data is skewed to the right and you use in the neural network algorithm and you try to predict an outcome. And let's say your accuracy is 70%. In some cases, when you transform your data to normal distribution, it could raise the accuracy of your model. For example, from 70 it could be 80, but there's no guarantee for that. So it's not just limited to normal distribution. In your final project, I expect you to try to improve performance of your model. What I mean, performance, accuracy, ROC, those kind of things. And I look at your effort. Maybe one effort could be transforming your data to normal distribution. And then you may or may not improve your model. That's fine. I just want to see you did some effort for increasing the performance of your prediction. These are the general things that you might do in your data preparation part. Data consolidation means collecting data, select data, and integrate data. And you might remember we did inner join in the Tableau, so we consolidate our data. Data cleaning, maybe you need to impute the missing values, reduce noise, eliminate inconsistencies or outliers. Or let's say you want to do prediction for the patient and your performance is not great. One of the way, maybe you have a justification saying that you have pediatrics and adults. Maybe you just separate them. They are not consistent patients. And you do model one for pediatrics, one for adults. And you increase your accuracy of your model. Data transformation, like normalizing, discretizing, and I talk about them later. And data reduction, reducing number of variables and cases, or balance skewed data. Reduce number of variables. Estimate, I mean, these are very complex topics. Hopefully you have enough time to cover all of them. Well, let's say in some prediction, let's say you have 100 variables. If you use too many variables for your model, sometimes your accuracy of your model is bad. So what we do, do you remember I talked about overtraining? So when you have too many variables, you might overtrain your model, and you make a model that is very good on a train set. But when you use a test set, it couldn't have a good performance. Or a better term is overfitting. Sometimes when you use too many variables, you overfit your model on a certain train set, and you cannot generalize your model. In such a case, one approach is doing feature selection or variable selection. We use some models that instead of using 100 variables, they pick the 20 variables. That 20 variables help your model to have a better prediction. So sometimes you need to focus on the most important variables for have a better prediction. But no worries, I mean, we have some examples that you would see. I mean, again, one of the ways that we do variable selection for improving the performance of the models. Also, when you have less amount of variables, your calculations is much less, and you might do a faster training or faster prediction. So we talk about bias and precision. Okay, bias, we talk about that. And also precisions is in predictive analytics, it's talking about a standard error of estimations. So we want to have a smaller standard error and also smaller bias. Bias means differences from actual prediction and from actual value and prediction. Bias is talking about a standard deviation of predictions. For example, in this one, figure A, the mean of prediction and mean of the actual value exactly same. There is no bias, but there is some standard error or a standard deviation. In figure B, the mean of distribution is here, the actual mean is here. So there is some bias for sure, and we have a standard error. In figure C, we have the smallest standard error, the best precision, and very small bias. But in the D, you have bias, and also you have a larger standard error. So largest standard error is graph B. The smallest standard error is in graph A. Okay, let's talk about neural network. The reason that they call it neural network, I mean, the structure of a neural network algorithm is similar to human neural network. Basically, there's two neurons that, I mean, in your brain, they have some inputs. So first neuron gets some inputs. It could be from your eyes, ear, whatever. They transform it through electrical pulses, send it to next neuron, and the pulses maybe get stronger or weaker, or there is some changes on pulses, and they transfer to the next neuron. They do some calculations, or they do a little bit of changes, and send the pulses to through the axon. I mean, the shape is kind of there is some similarities. So you have some inputs, and the inputs would multiply to a number and transfer it to next neuron, and just go layer by layer, and at the end you have outcomes. So I know it might look very weird for you because it's first time looking at that, and you don't need to do calculations. You just need to know your inputs would change to some numerical value. You multiply those numbers to something. Each line here, if I have a better shape, maybe this shape is better. So you have some inputs, x1, x2, xn. Each line means a multiplication. So you multiply that input variable to a number and send it to next neuron in the next layer. And in that one, again, they go through a function. For example, input from different lines are 2, 3, 4, 5. If you sum them up, it would be 14. And let's say inside this node, we have a sinus function. No, not sinus. Let's say there is a ln. So natural logarithm of 14, which I don't know. And again, this one would be sent to the next layer and multiplied to some numbers. I just summarized neural network in less than 2 minutes, but just want overall telling you that your x1 to xn, which is your input variables, would multiply to something, go through some function, and at the end, that's good. At the end, it could be a probability. Let's say in this easy example, I have several input variables as my independent variable. They went through some multiplication, some functions, and at the end, my value is 0.8. On this figure, let's say here, the output is 0.8. And I have class 0 and class 1. If the outcome is 0.8, does it belong to class 1 or class 0 if my threshold is 0.5?
Class 1.
1, yeah. It's more closer to 1 So it depends on your threshold. If your threshold is 85, 0.85, and the outcome of neural network is 0.8, you might say class 0. This is a very easy example. There is something similar in regression and also multi-class classification. I'm just telling you that in machine learning algorithm, there are black box algorithm. We cannot explain why in each line here, each line we put different coefficients, and why we use different functions. So each blue dots refer to a function. So, but there is some internal algorithms that through some try and error finds the coefficient of each line and also the functions that can use for prediction. In a statistical models, you can prove it, but there's not a case in machine learning algorithms such as neural network. Go here. Basically, first, the way that it works, the internal algorithm just assign some random coefficients to each line. Let's say, just say each arc or line has coefficient of 0.5, then then you send the input, multiply to 0.5, sum them up, and let's say here we have ln, and at the end we just sum them up, and here we get 0.8. As Punavit said, we say since the outcome is 0.8, we would say it belongs to class 1. But actually it's belonging to class 2. So, sorry, class 0. So there's an error. So again, model changed those coefficients. If this time the outcome is 0.4, it would say now it's class 0, and actual observation is class 0. So it learned those coefficients that the model found are right. So again, there's some try and error approaches, but these are through search algorithms that computer science students learn how to make those search algorithms, how to find the coefficients that you should use for each line. But for you as an analyst, you need to know how to use modules, how to find inputs, and how to introduce the inputs to the modules, and then talk about precision of your models. We don't, as you see, this is a black box, which is a gray box here, but we don't look at inside. We just focus on how to introduce input and how to evaluate our outputs. Sorry, we don't have that for time, but I'll explain neural network in 5 minutes. And these are some softwares, Neural Solution, BrainMaker, NeuralWay, NeuroShell, or it could be a part of SAS, IBM Modeler, RapidMinder, and KNIME, and many more algorithms. So we use KNIME. So although neural network is, even regression is a complex algorithm. So I used to teach how to and prove regression equation, and you would freak out. So when even regression is a very old model, looks very easy one, but when you do y equal a times x plus b, even that proof takes 1 page of mathematical proof. So, but you never ask how we find y equal a times x plus b. You just use that, and you just use Excel, put y column and x column, and you find the equation. So, but the actual equation under the hood is really a complex equation. You can just Google it. I mean, I think there you can find it on the list. One of the ways to find regression equation is through the least square approach. You can find there is a very complex equation, a proof behind of linear regression. But no worries. I mean, similar to linear regression. So in Excel, you just select Y column, X column, and it gives you the equation. Even neural network, you don't take care of the under the hood. You just say, this is my X, and I want to predict Y. That's it. So let's talk a little bit of supervised versus unsupervised learning. Punavit was my previous class and also other classes, so for him it would be boring, but supervised learning is for the cases that you have a Y variable that we call it target or label. So when your data is labeled, for example, we talk in the neural network, we say we have class of 1 and class of 0. So, or let's give you a real example. For example, you want to check the tomorrow's stock price of Apple, and you want to see either it's increase or decrease. So up label, up and low labels, or the actual value of the Apple price tomorrow. It's a continuous variable, and still we call it supervised learning. How it works, you look at the previous days, and you have Apple stock and other variables associated to Apple company, and with those variables you predict the Apple stock. So this is supervised learning. Also, we have unsupervised learning, similar like clustering. Actually, for who study marketing, unsupervised learning is very important. For example, you have a limited marketing budget, and you have a pool of customers. A non-analytical approach is just using same marketing campaign for all the customers, or use a clustering approach. Look at this figure on the right. You divide your customers to groups based on their similarity. One similarity measure is just closeness in your Euclidean space. We just pick these 3 groups because these points are closest to each other. But in your customers pool, you might have some customer with you have income, gender, ages, locations, so on and so forth. So basically, a female in Worcester might see a different ad than a female in Bangladesh or other part of the country. All of them use YouTube. YouTube is open in Bangladesh. In some countries, they cannot access to that. So, but the ad that somebody sees in Bangladesh might be in the Bengali language, if I'm right, with a certain like thing that the female customers can see, could be interested for those female customers in Bangladesh, but for some female customers in Worcester is different, or for male customers in Boston might be different from a male customer in California. So for such a case, especially in the marketing, you divide your market in different segmentation and choose different approach, or invest wisely on your ad campaign. These characters could be usage-based, demographic like gender, age, family, and psychological characteristics. So at the end, we want to, based on our budget and a strategical plan, we just divide our market to different segmentation, and for each segment, we just focus and invest differently than others. For example, even in, let's say for the next US election, they use different ads for different peoples. Maybe there's a conservative guy, so they look at their YouTube usage. Maybe they see they are just looking at the certain age. They are looking at let's say I just through example, maybe it's right or not, and I'm not Facebook, but or YouTube. Maybe there's somebody who's watching luxury items, and in the southeast, and don't watch anything related to Black Lives Matters. You might guess he could be from different race and age and income level. Then somebody might watch so many Black YouTubers from, let's say, north of United States, and they are looking at how to find different deals on the internet. So you might say it could be different people. So for this, or maybe we have millions of types of customers. Might be somebody is looking at luxury items, he's looking at the videos related Black Lives Matters, and they're from center of United States. I don't want to judge them. I just want to say, based on those their browse history, they might do segmentation and use different ad campaign for the next US election. So, for example, you are you are from China, I guess. Have you seen some Chinese ads in the United States in YouTube, or all of them are in English? Have you seen some Chinese? So what they did, they didn't ask, are you Chinese or not? Have you seen some Bengali ads? No? Okay. So maybe you just include them to, maybe they could even guess you could be from Bengal, but could you know Hindu or Urdu languages? No. So for you, maybe they just said, just include him into English market. Because for sure in the US, he knows English. Maybe they don't have that much of Bengali customer. I just guess, I'm not sure it's the reason. But for Chinese, they have a big Chinese population here, and they say, okay, for them, let's target them and just give them some ads in Chinese. So it's just different strategy. It's one of the reasons in the last election, if you might remember, they are just blaming Facebook and YouTube and those kind of companies for meddling in the election. It's a hot topic, and even they call them to the Congress for that. So it just showed the importance of that. And at the end, people should decide about their decision, and nobody should meddle to do the meddling. It should be fair competition anyway, but maybe election is a good topic, I think, based on races. For example, I speak another language too, but I never saw any ad here. They include me into English market. But for Chinese, there's a good amount of Chinese here. So they say, okay, maybe we can make more money if just give them good ads. So anyway, is there any marketing students here? You? I think you were in finance. You finance, so yeah. So yeah, you maybe if you are in the, let's say if they hire you in the Facebook or YouTube, you might say, no, there's so many Bengali like people in the Boston, so just use different ads for them. But Bangladesh is a very large country. I think it's 200 million people, right?
The country is very small actually.
No, I mean population-wise. Yeah, I mean Russia is very large, but I think that the population is less than Bangladesh. I think it's more than Russia, I guess. Yeah. I mean, it depends. I mean, we talk about segmentation. And actually, it could be good, even for the election. I'm thinking of maybe they can do some analysis based on their ads and might just blame them. You are not fair. You're doing middling and just using some countermeasures for having a fair election. But it's a very hot topic, and I'm not a professional in it, but I just guess it could be used for that too. So. Here I put some details of K-means clustering. Is one of the clustering algorithms. I don't expect you guys to do note the details, but just randomly you assign some center points then assign the observation to those points randomly, and just try to improve them one by one, step by step, and just at the end you divide your observations based on the distance. But anyway, at the end, I don't expect you guys to explain me k-means. You can also just do some YouTube, but basically just some loops that just goes through the loops, reassign the points again and again until you have the smallest amount of error, but it's not is out of content for this class. Clustering. Okay, next class. Okay, we almost ran out of time. Next class, we do some further machine learning projects through NARM. I try to show you how to find outliers, how to do imputation, and also there is some important topics. For example, let's say, I think you've never been in my programming class, but let's say I have one column of country. So I went to the marketing campaign, and based on the browse history, I can find somebody's from China, somebody's from Bangladesh, some from India, or other countries, or United States. So that column is a string and is not numerical value, just country name. But in your models, even all the machine learning algorithms, your input should be numerical. So you also need to know how to convert that string, a non-numerical column, to equivalent numerical values, which I talk about in next class. Or you could do image processing. You need to know how to convert image to a numerical equivalent and then do analysis over that. Okay, that's for today. Again, the examples are arbitrary. I hope it was not offensive for some countries, but it's just some examples that came in my mind. Thank you very much, and that's for today.